You notice something in your own numbers. The months you spent more on ads seem to be the months you got more signups, and you start to wonder whether you could turn that loose hunch into an actual number. If I spend this much next month, roughly how many signups should I expect? That question, drawing a single line through a messy cloud of your own dots and reading a prediction of it, is the whole idea behind regression. And today I want to talk about what it really does for a small business and where it will quietly lie to you if you let it. I am not a statistician and I am not a data scientist. I am someone who runs small businesses and spent years just eyeballing my charts and guessing at the trend. I would squint at a scatter of months, decide it looked like it was going up and to the right, and lean on that feeling far harder than a feeling deserves. Regression is the plain habit I now use to replace that squint with one honest line, while staying humble about how far that line can actually carry me before it starts making things up. So let me say plainly what regression actually is. At its heart, it is fitting a straight line through your data so that from one number you can estimate another. The number you already know or control goes in, your ad spend, your visitor count, your price, and the number you care about comes out, your signups, your sales, your revenue. One line standing in for a whole relationship so that the value you have goes in one end and the reasonable guess comes out the other. Before you draw any line, you plot the dots, and honestly, the dots alone teach you most of it. Put your input along the bottom and your output up the side, and let every month land as one point. Now look at the shape of that cloud. If it forms a fairly tight band that climbs from left to right, there is a real relationship in there worth measuring. If it is a shapeless blob with no lean to it at all, then no line, however clever, is going to rescue a relationship that simply is not there. When there is a trend, regression finds what people call the line of best fit. That is the single straight line that sits as close as it possibly can to all of your dots at once, splitting the difference so the total distance from the line to the actual points is as small as it can be. Each of those little gaps, the vertical distance between a real month and where the line said it should be, is called a residual. Best fit simply means the line that makes the whole pile of those misses as small as possible. The number you will use most is the slope, and it is worth understanding in plain words. The slope tells you how much your output moves for each 1 unit you add to the input. Treat this next figure as illustration and not a benchmark to copy. But if the slope came out around 30, that would mean every extra $100 of ad spend was associated with about 30 more signups on average across your history. That one number, how much moves for each unit you push in, is the working payoff of the whole exercise. And it is the one figure you can actually carry into a decision, because it answers the only question that really matters. What happens if I push a little more in? The line also has a starting point, the place where it crosses zero on the input, and that is called the intercept. Sometimes it means something real, like the baseline signups you might get in a month with no ad spend at all. But very often, zero sits far outside anything you have ever actually done, and the intercept becomes a number your data never really visited. So read it gently and never lean your plans on a corner of the line that your real business has never once set foot in. The next thing to read is how much you should trust the line at all, and for that there is a number usually called R squared. It runs between 0 and 1, and it tells you what share of the ups and downs in your output the line actually manages to explain. A high value means your dots hug the line tightly, and the input really does carry most of the story. A low value means the line is real but weak, and most of what moves your output is living somewhere the line cannot see. Here is a warning I have to keep planting every time this subject comes up. A fitted line proves that your two numbers move together across your history, and it proves absolutely nothing about one of them causing the other. Your ad spend and your signups might both climb every busy season for reasons that have nothing to do with each other, and the line cannot tell the difference between a genuine lever and two things that simply rise together. A slope is a description of the past, never on its own a proof of cause. The single biggest trap with regression is that the line will happily draw itself out to infinity, while it is only trustworthy across the range of inputs you actually observed. If you have never spent more than $1,000 in a month, then the line's confident guess about spending 10,000 is pure fiction dressed up as arithmetic. Real relationships bend, they saturate, they hit a ceiling and break, and a straight line has no idea any of that is coming. Stay inside the range you have really lived in. You also want to watch for a single strange month bending the whole line toward itself. Because best fit is trying to please every dot at once, one freak point sitting far out on its own can quietly drag the slope in its direction and tilt the line away from the truth the rest of your data was telling. So before you trust any line, look back at the scatter and ask whether one odd month is secretly steering the entire result, and what the line would say if that one point were not there. It is worth being honest that the plain version of regression assumes a straight line, and plenty of real business relationships are not straight at all. Spending more on ads often helps a lot at first, then helps less, then barely helps as you exhaust your easy audience. If your scatter clearly curves like that, forcing a straight ruler through it will flatten out and hide the very bend you most needed to notice. Always let the shape of the dots tell you whether a straight line even belongs on the picture in the first place. In real life, your outcome usually has more than one driver, and the same idea stretches to handle that. You can feed in several inputs at once, your spend and your season and your price together, and the method will hand each one its own slope while holding the other steady, so you can see each effect on its own. That is genuinely powerful, but the more inputs you pour in, the easier it becomes to fool yourself. So add a new one because you have a real reason to, never just for decoration. That leads straight to the mistake people make the moment they get comfortable, which is piling in input after input until the line fits their past almost perfectly. The problem is that a line stuffed with variables stops learning the real signal and starts memorizing the random noise in your particular history, so it looks brilliant on the months you already had and predicts the next one terribly. A simple line you fully understand will nearly always beat a complicated one you cannot see inside of. The good news is that you never have to do any of this arithmetic by hand. A spreadsheet or any basic analytics tool will draw the line and hand you the slope and the R-squared in a couple of seconds. So the real skill was never the calculation, it is reading that output honestly. Is the trend actually there? How strong is it? Across what range of inputs can I believe it? And is there something obvious that could be driving both numbers at once behind my back? None of those questions need a single formula. They only ask you to stop and actually look at the picture and the range before you trust the number the tool just handed you. And when you finally use the line to predict, resist the pull to treat its answer as a single hard number. The line gives you one tidy guess, but the honest version of that guess carries a bend around it, because your dots never set perfectly on the line, and next month will not either. So read a prediction the same humble way you would read a forecast, as a center with a spread on either side, wide when your dots were scattered, and tighter only when they genuinely hugged the line. Let me pull it together with a rough feel, and again please treat every figure as illustration rather than a target. Suppose across a full year, your busier ad months clearly brought in more signups, so you fit a line and the slope lands somewhere near 30 signups for each extra $100, while the R-squared tells you the line explains a good chunk of the swing but nowhere near all of it. That combination is exactly the honest reading, a real effect you can lean on gently with plenty left over that the line freely admits it cannot account for. Every one of these explainers lives in writing at dataresearchanalysiscollections.com. The whole metric library in plain English, with regression worked through on a real messy scatter of months rather than a tidy textbook line. So you can watch the slope, the R-squared and the residuals come straight off your own numbers. I keep it honest there for the same reason I keep it honest here. No promises about your results, and no pretending that one line settles a business that is really being pushed around by a dozen things at once. Read it slowly with your own scatter open beside you, and hold the whole idea in proportion. Regression does not create a relationship, it only measures one that was already sitting in your data, and a confident line has never once made the future agree to follow it. It will not prove that your input causes your output. It will not survive being pushed past the range you actually observed, and it will not conjure a trend out of a shapeless blob. All it really buys you is one honest summary of how two of your numbers have moved together, and a humble guess that is only as good as the history it was built from. So to recap, regression fits a single line through your data so that one number can estimate another, and you read the slope for how much your output moves per unit of input, the R-squared for how much of the story that line really explains, and the residuals for where it missed. Trust it only inside the range you have observed, never as proof that one thing caused another, and never past the point where your straight line stops matching the shape of your dots. Next time I want to talk about the correlation coefficient, that single number that measures how tightly two things move together and how it quietly sits underneath the R-squared you just met. I will see you in the next one.